In this recording, we're going to explore average rate of change, specifically comparing a linear function to a quadratic function, and kind of see how they compare, how they contrast. Well, average rate of change is pretty much the change, that's what this delta, this Greek letter delta looks like a triangle, change in the y value, or the f of x, divided by the change in the x value, or the change in the output divided by the change in the input. That's another way to say it. And of course, change is measured by subtraction, right? What was the change in temperature between yesterday and today? Well, you would subtract, right, yesterday's temperature from today, and you would have it. And so we're always going to start with the first one. We're going to subtract A from B. I guess I messed that up when I said the first one. We're going to subtract A from B, so we're going to start with the second one and subtract the first. All right, so let's get into that and do a couple calculations. I'll kind of work with you on the first one, and then I'll have you work on the second one. So you got to kind of concentrate. Let's make sure we're blocking out. Let's not see this at all here so we don't get confused which numbers we're using. Maybe you want to use a little something to cover up that. I know when I was working through this, I kept getting mixed up, like which x are we talking about, which y. So if I want to work out the change in f of x, over the change in x, that's simply going to be, I got to find out what the y values are. Maybe the best way to show you what the y values are, so it doesn't feel like these numbers are coming out of thin air. This is the function, y equals 5x plus 7. If we look at the table, we're interested in the y values for the x values of -2, which is -3, and +3, which is 22. So I'm going to capture this little piece of table. So now that we know what the y values are for those particular x's, we can subtract the y values. So subtracting, this is the f of x column, right? The y's, and this is the x column. So I can go 22 minus -3. Then I can do 3 minus -2. I have to be really careful when I'm subtracting negatives. Okay, I treat that as a plus positive when I see subtraction of negatives. I'm just adding. And of course, that's 25 over 5, which is 5. All right, now for comparison, I'm going to get rid of this table because that was only relevant for f of x. So we're going to go back to the calculator, and this time our function is the g function, 2x squared plus 1. Of course, we could do this in our head, but I'm just trying to illustrate, because I know sometimes students say, I don't really get what those numbers came from. 2x squared plus 1. Now I'm going to look at my table, and again, it's between the x values of -2 and +3. So I'll grab a little screenshot. Okay, so one more time. This is our x column, this is our y's. We're talking about the g function, so obviously we have different values of y, but the same values of x we're speaking about. So average rate of change, it's basically slope, right? Change in the y, which in this case is a g, over change in x. Rise over run, right? So our change in the y goes from 19 down to 9. So I'm always doing the one that came later minus the one that came earlier. So this is like my y1, y2, x1, and x2, if you like that. If you want to think about like back in our slope, finding slope, change in y over change in x, rise over run. And 3 minus -2 is going to come out the same as it did before. I got to be really careful with my negatives, but I know I can just make that easy by making it plus plus. 10/5 is 2. Okay, so hopefully that made sense to you. The next one, I'm not going to show all the table, but feel free to use your calculator to get those y values from the table. Okay, so we can clearly see here the average rate of change is 5 for the linear function f. The average rate of change is 2 for the quadratic function between -2 and 3. All right, so now let's switch it up. Let's have us move this little cross out. You can cross that one out over there. We're going to ignore that altogether. We're just going to focus on these x values, the interval between 1 and 5, and see if it's the same or if it's different. So why don't you pause the recording, play it only when you've got both these worked out. Okay, so hopefully you worked these out. I'll speed it up for you so you can see it super fast. Okay, so let's check it out. Let's do some comparing and contrasting. The average rate of change for f was the same for both I and double I, all right? Both 5s, right? And you think about what shape is that? Well, it's going to be a line, all right? No surprise there. And it was not the same for g. And I think if we look at the graph, that will tell us a little more about what's going on here. So I made a little screenshot of this graph, and our linear function, doesn't matter which x values you're talking about, the rate of change, how much the y goes up for every time the x goes up, is the same, right? Linear functions have a constant rate of change, so jot that down in your notes. Quadratics do not. It depends on which particular x interval you're discussing in terms of how the average rate of change will be. Thanks for watching.